Hi, this is another episode where I take a stab at machine learning, and as usual, it turns out okay-ish. I'm learning a lot. When you look up generative adversarial networks, you'll see pictures like these, fake celebrities invented by a computer. My own generative adversarial networks can produce very nice numbers and even Pokemon knockoffs, which I call blorpomon. But how can I make a good picture, high resolution, like these? Well, these pictures were made by StyleGAN. How does StyleGAN work? Oh, it's complicated. But the first complication is that it's a progressive GAN. Let's think about it. I've previously described generative adversarial networks using a metaphor based on the game Animal Crossing. Red is a shady fox who sells real art and fake art. The villager wants to identify the real art and put it in Blather's museum. Neither of these characters actually knows what real art looks like. They only learn by competing with each other. The villager buys a bunch of art, guesses which are real, and brings them all to the museum. The curator Blathers explains which ones are actually real. Blathers knows exactly what real art looks like. Then Red gets the villager drunk enough to mindlessly critique his fake art. So Red learns to make better fakes. These two steps repeat until, theoretically, Red's fakes look pretty good. But this setup only lets Red make art, which is fairly low resolution. The MNIST numbers are 28 by 28 pixels. Those Pokemons are 32 by 32, or by 3 channels for red, green, blue. How can Red learn to make art which is, say, 1024 by 1024? Well, we train Red and the villager progressively. Before we start progressing, one cool note: Red makes his fake art based on random numbers we give him. This can be called noise or seeds, but some tutorials call these points in the latent space. This took a minute for me to figure out. Consider an autoencoder, an algorithm which turns input into itself. This seems dumb, but if we cut an autoencoder in half, we get an encoder, which turns huge inputs into tiny little outputs, and a decoder, which turns those tiny little outputs back into those huge inputs. That bottleneck gives us a compressed, information-dense language using a low-dimensional latent space. So when we give Red random seeds, we're promising him, you're a decoder, and your encoder made this fresh garbage just for you. Turn the garbage back into real art. Red has to look at random numbers like they're clouds, and he's got to describe those clouds so the villager can see bunny rabbits in them or something. Okay, so progression. Red makes art of a particular size, and the villager appraises art of the same size. If we want to make bigger art, we can start by upscaling what Red comes up with, and telling the villager to start by downscaling it. The GAN is now creating and interpreting art of twice the height and width, 4 times the size. But the big art is just as simple as the small art used to be. So now we give the generator and discriminator forked paths to implement deeper tools. These new paths begin barely used at all. We handicap them so the simpler old paths are still handling most of the art stuff. Over time, the old paths give the new paths more control. In my last video about GANs, I thought blurring pictures less and less each epoch might let the algorithm learn large details before small details. I was thinking right, apparently, but this is the way to do it. So let's try mixing progression into that Animal Crossing metaphor. Red has a dog, and the villager has a dog. Red and the villager don't actually interact at all. Their dogs play together in their daily walks. These dogs are layers we eventually snip out and throw away. Okay, so Red is telling his dog how to make art by shaking its leash a little, and the other dog describes that art to the villager by tugging its leash a little. This metaphor is weird, okay? I'm trying, geez. Red has a kid, and Red's kid has a puppy. Red has 2 leashes now, one on his dog, one on his kid. He can shake one leash, and his dog makes art. He can shake the other leash, and his kid shakes his leash, so his puppy makes art too. Red's kid and his puppy have natural talent, making more complicated art, but they aren't good at art yet. So Red and his dog upscale their own art to help them out. The villager has a kid too, and the villager's kid has a puppy also. The villager's kid and his puppy have natural talent for inspecting more complicated art, but they aren't good at art yet. So the villager and his dog downsample art to interpret it alongside them. As the kids and puppies grow up, their parents and their dogs let them handle more and more of the art, until eventually the parents let their dogs go into the wild and just shake their kids' leashes instead. Someday the kids can have their own kids with their own puppies, and so on. The successors can handle higher resolution and more detail because they're linked to their ancestors, basically. Isn't that wild? I just love this. I managed to implement the idea in PyTorch. It's an alternative to TensorFlow and Keras I totally recommend. I used attention-augmented convolution too, and the dogs can see in a whole lot of color spaces at once. My progressive GAN turned out pretty cool. Here, let me run through one of its attempts. These are real face pictures from Flickr, which are 128 pixels by 128 pixels. I'm going to scale them all the way down to 4 by 4. Now, on the left, we've got fake faces. The generator hasn't trained at all yet, so they don't look like anything at all, do they? But after some training, those could be faces. Why not? The left and right look more or less the same. Now Red and the villager have kids who think in terms of 8 by 8. Each epoch, the power transitions to the kids, until eventually they're in control. Now the kids have a few epochs to themselves. Then they have kids too, and the faces transition to 16 by 16. Speeding up a bit, if I hadn't made these faces myself, I might be convinced these were just real pictures fed through some sort of filter. There are a lot of parameters I could try fine-tuning, but I think I've taken a nice first step, which is what I'm always aiming for here at Thinkster. I'll get better and better, progressively. Before we go, let's try making some more blorpomon. Well, see you next time. Bye-bye.